important case and very understandable to be considered. Note down over here, like being an investor. If I'm taking up you as an investor, what you always plan to invest, right? And as an investor, you want to invest in what? You want to invest. So the scenario given in this case is like you being an investor, you want to invest in securities. And when you are investing in security, I'm giving you an example that you are investing in a two securities taking A and B. Right? The risk we have given a return. In the first point that we have given a return. What is the return that we are expecting? So now we are given a return that A is expecting a return of 9%. A is expecting a return of 9% and has a risk factor of 5 on a scale of 0 to 10. Right. This is information provided to you. The second one is information is that if I'm talking about the security B, if I'm security B, then security B will provide you a return of 15%, but has a risk factor of from 5. Now we have the risk factor of 10 on a scale of, or take it not 10, or take it as an 8, right? Again on the scale of 0 to 10 only. This is the point. A and B has the risk and the return. But one more information which is provided in this case scenario is that the total amount of maximum investment that the investor can do is we considering it as 5 lakh rupees. This is the total amount of investment. We have taken a $5 lakh, or you can go in Indian rupees also. This is one of the case, so I'm assuming it as a $5. One more information is provided to you in this case is that the total minimum return on the investment, total minimum return on the investment should be also, yes, that the maximum, we have the capacity requirement. So we have the maximum combined risk. This is the combined return of the two investments. So we are taking the maximum combined risk. What should be? That it should, maximum risk that should not be more than 6 investors. Now you are required to formulate this element. Hope you are able to understand what are the information given to. Just having a look once again. We have given a, like we are using this linear programming question in the investment decisions, or we are taking in a portfolio selection. We have given as an investor has given a two securities, and the security is given a return of 9% and as a risk factor of 5 on a scale of 0 to 10. And the security B that gives you a return of 15% that will at a risk factor of 8. Again from the scaling 0 to 10. And the total amount of investment done by both the investor is 5 lakh. And the total minimum return on the investment should be 12%. And the maximum combined risk should not be more than 6. This is the information formulate, and you have to formulate the linear programming equation. So this information, while considering this information, are you ready to formulate the equation? How we will use these formulations? Again, using the previous concept only. What we have to do? Again, first we have to take a decision variable. The first one is your x1. That will be the amount invested in security A is we taking it at x1. Amount invested in security B is x2. Now, second point is your objective function. Your objective function is definitely to maximize your return on the total investment. That is maximizing the Z. And now here, how much maximization of the return is there? That we have given 9% return on security X and 15% on security Y. Then second constraint that is related to total investment. Whatever investment we can do in X1, X2, but it cannot be more than 5 lakh. Second related constraint is related to the risk. What is that risk? That we can take a maximum risk of 6%. That is, for 5 lakh we can have it at 6. It should not be more than 6. So 5 lakh into 6, that will be 30 lakh. One more constraint that is over here is related to return, as we have given the return of that securities. And what can be the return? That is 9% in X, right? And the 15% in X. 2. That is a B security. And but the maximum constraint is 12. Now the maximum constraint is 12% return. That 5 lakh over 12%, that will be 16,000. And the last but not the least is the non-negative constraint, that is always be taken as security x1 and x2 should be greater than 0. Hope you are able to formulate all this. Now coming up with your words, take the pen and paper and formulate with me. Start writing it. The first point is your decision variable. See, whenever we're doing the numericals with the pen and paper, it will become more strong. So write it. X1 is your the amount that is invested in securities A. X2, you can take any variable A or B. You can take it X for X and Y. That is amount invested in security B. This is first point. That is a decision variable. The second one is your objective function. And that objective function will be again is to maximize your return on investment, that we all want to have it. So what is maximize Z is equals to 9%. So 9% will be 0.09 if I'm talking about in a percentage, plus 15%, that will be 0.015, right? 0.015 x2. 9%, as we have given, you can write it in bracket also, that 9% will be equals to 0.09, and for 15%, if I am talking about, it will be equals to 0.015. No, not 0.15, it is only 15%, sorry. That will be taken as 0.15. So sorry, over here, we write it 0.015, right? 0.15. Okay, this is what we have given. Now we're coming up to the next point, that is our constraints. So write down all the constraints over here. What are the constraints as we have discussed? First is related to your risk. Like risk constraint is there. So how much risk is there? We are ready to take 5% risk in security X. So 5x1 plus 8x2, and the risk, we have the combined risk of 6. So in bracket write it 6, and the total amount invested is 5 lakh. 6 into 5 lakh. So just you can solve it also. 5x1, 8x2, that will be equals to, multiply this value, that will be 30 lakh. Right? This is the first point. Constraints related to risk. Now we are having the second risk. That is, even that first second point, we also have a total amount of investment that is related to investment point. So write it over here in an investment, that we can invest maximum 5 lakhs. So x1 plus x2, that should be not more than 5 lakh. So maximum can be 5 lakh only. This is also one of the constraints. And then one constraint that is related to your return. Right? What is the maximum return? We can have it 12%. So 0.09x1 plus whatever it is, 15%, and the second one 0.15x2. That should be equals to, that is 12%. That is 0.12 into 5 lakh. Right? So 0.09x1 plus 0.15x2 is equals to 0.12 multiply 5 lakh, that will be equals to 60. And the last but not the least is the favorite one, that is non-negativity, negative constraint, and that is related to x1 and x2 always be equals to 0. So this is the way we have done the investment portfolio. Now equating these values with the help of normal mathematical equation, as well as when we are doing the step by step. When we proceed further, we will use the simplex method as well as the graphic method to find out the quantity of x and x1 or x2. So this is the way we can solve our problems of linear programming in the different fields. Now coming up to the next example, in the next how we can use it. Now I'm taking a next case scenario of using this LLP in the inspection problem. See, I told you earlier also that this is LLP that can be used in different ways, in the different formulations we can use it. So now what we have taken a case, say example, now we take a case of, okay, inspection case we have taken up, okay, write down. A company is there, like it has given a two grades. Company is given a two grades of inspection. I'm writing with you the case also so that you're able to understand what we are there. I'm with you only, right? We have given a two inspections first and second. This is the quality of my session that you can like upgrade with me only, that I am doing with you. Don't worry, like you are not, I am not sitting with you, I am exactly in front of you. You can ask me all the questions also. So start doing in that way. We have given a two grades, right? And undertaken the quality inspection. The grade quality one has come up for taking your quality inspection. Like we have covered a quality control inspection. Right. Now it is also given that at least 1500 pieces must be inspected. This is what they are saying it in the case. In 8 hours per day. The first one is this, that at least 1500 pieces must be inspected in 8 hours. The second point that they are telling you is the grade 1. Now they are saying it that if I'm talking about the grade 1, we have given two grades, now first and two. So one is that one inspector, grade 1 inspector, what this saying is that they can check at least 20 pieces in a hour time. In 1 hour they can check it. And the accuracy, but they can check, inspector can check 20 pieces. And if I'm talking about if they are checking 20 pieces, then we have to talk about the accuracy, and the accuracy rate is 96%. Right. But if I'm talking about the grade 2 inspector, we have the grade 2 inspector also, who also get checked with all these quantity of goods. So talking about grade 2, when we are talking about the grade 2 checking, they are doing 14 pieces. That is doing 20 pieces. Now it is 14 pieces, and that too within a hour of time. But now if I'm talking about the accuracy level of this inspector is, this inspector have an accuracy of 92%. Right. Now further, what will be the case in this? Now we have given a more case, now then only we can equate the equation. So next point over there is the wages. If I'm talking about the wages of grade 1 inspector are rupees 5 per hour. Right? While those of a grade, if I'm talking about the wage of grade 2 inspector, if I'm talking about the wage 2 inspector has a grade of inspection cost, or you can say it like what the inspector is coming up, so how much they have to charge it or how much we have to pay, then we are paying it only 4 rupees for per hour. Right? But if I'm talking about the error, if any error that we are doing the error also, no? If any error is done by inspector, error definitely will be there. Then if it made by the inspector, then it is a cost of rupees 3 to the company. This is also the information given. The next point is, if there are in all 10 grade, 10 grade of one inspector and 15 grade of second inspector. Different grades. So we have taken 10 grades of inspector 1 and 15 grades of inspector 2 in the company. Then you as a linear programming manager, you have to find out the optimal assignment of inspector, and that too, that is the important point, that minimum, that minimum the daily inspection cost. The daily, that you have to minimize, what you have to minimize, that the daily inspection cost should be minimum. So yes, this type of a linear programming with case studies is over there. Just summarize one thing. A company is having a two grades of inspector, inspector 1 and 2, that undertaking the quality control inspections. At least 1500 pieces must be inspected in a 8 hours per day. Grade 1 inspector will check it, they check it over 20 pieces in an hour. But if I am talking about the accuracy level, that is 96%. But if I am talking about the grade 2 inspector, it always checks 14 pieces as an hour, and that to an accuracy of 92%. But if I am talking about the wages of the grade 1 inspector is are rupees 5 per hour, while those of the wages of the inspector is 4 per hour for the grade 2. If any error, if I'm talking about the error by an inspector, if any error will be there by the inspector, that it will be cost rupees 3 to the company. If they are all together 10 grades, it is given in the question in the case study that it will be there 10 grade inspector of category 1, and there will be a 15 grade for second. So before being you, that you as a quantitative manager, being you as a finance manager, you being as a linear programming manager, you have to find out the optimum assignments of the inspections. That too, that will maintain a daily inspection cost. You have to maintain the minimum inspection cost. So this is the whole scenario of a case. Are you able to get it what the case scenario is? Now what you have to do, you have to formulate all this scenario in such a way so that your answer should be in the minimum way. So what we have to do again, we have to remember that 3 steps basically, what are the main point as we are getting the 2 grades. So what we do it over here, we're taking it like x1, noted with there only, let x1 and x2 will be denoted as the number of grades for one inspector and number of grades for second category of inspector to be assigned for the job quality inspection. Now we coming up to the next point, that is the main important thing in this scenario is that the getting the objective. What is the objective over here? Now it is the objective as a daily cost. That is the cost of inspection should be minimum. That is the main point over here. And the what the type of inspection can be occurred of, as we have discussed that it is given as like it will be incurred the inspection cost. But what is the amount of the cost of inspection? We calculate that cost of inspection for both the grade. So calculate this cost for grade 1 inspector. Like we have to find out. So for grade 1 inspector is 5 plus 3 into 0.04 into 20. When we calculate this value, we get it as rupees 7.40. But if I am talking about the grade 2 inspector, calculating the like rate for the grade 2, that will be 4 plus 3 into 0.08 into 14, and that will be equals to rupees 7.36. Would you be able to find out how we calculated this value? See, it is given how much quantity as just we discussed twice the case study. We have given 20 quantity that is done by the grade 1, and we have given the grade 2 will done the 14, right? And what is the like accuracy level we have discussed of 5 rupees cost is also been occurred in by the grade 1, grade 2 income 4. So we just apply that equation. Now if I am talking about the objective function over here, what is the objective function? So note down over here, objective function. What is the objective function? So note it over here that we want to minimize our z, and that value is, what is the minimum value for this that we have calculated right now, 7.40 and 7.36. So multiply that 8. What is this 8 which we have taken up, which is given in the case, right? What is the accuracy level for the grade 1 and grade 2? We have given 8 hours per day. So 8 we take it, and for 1 per day we have calculated 7.40 for product of a grade 1, right? So for 7.x1 x1 grade 1, and we have given for grade 2, so we take it to the x2, 7.40 x1, 7.36 for x2, multiply with this 8. So multiply, open this, calculate the value. 7.40 multiply 8 will be 59.20 x1. 7.36 multiplied by 8 will be, multiply this value, that will be 58.88 x2. Right? So this is the objective. Now coming up to the next one, that's the constraint. What will be the constraint? So writing over here the constraints. Find out the constraints. First, on grade 1 inspector, that 1 cannot do more than 10, right? And the second one is for grade 2. What is the grade 2 inspector? Write it. On number of inspection by the grade 2 inspector, that number x2 cannot be more than 15, right? And the next point, that the on the number of pieces inspected daily. How much inspection can be done daily? 20x, 20 units. You can write it in this way, 20 multiplied by, right? In this way you write it. 20 multiply by 8 x1 plus, for the second one, 14 units into 8 x2, right? And that should not be greater than 1500. So multiply 8 to the 16, that is 160 x1 plus 14 multiplied by 8, that is 112 x2. That should be greater than equals to 15. And one non-negative constant is always there, x1 and x2 value, that is always be equals to 0. That cannot be negative. So this is the way we have used the linear programming in your inspection area. So we can use in different ways, varieties of ways.